Okay, welcome to this video on problems with quadratics. I don't mean that there's issues with quadratics. I mean we're going to look at maths problems involving quadratic equations. Okay, so our first example is going to look at area of a rectangle. Now the area of this particular rectangle is given as 204 square centimeters, and we need to find out the dimensions and the values of x for an area of 204. Now if you can recall the area of a rectangle, which is going to be the length multiplied by the breadth. Length is x plus 5 and the breadth is x. But before we go with the equation that we'll set up, just make a big note that in this case x cannot be equal to 0, because if you had a width or a breadth of 0, you actually won't have a rectangle. So x has to be a positive value. There's no negative values for x because there's no measurements that have a negative value. So in order for us to look at this problem, we need to make sure that x is going to be greater than 0. So just make a big note of that. X is going to be positive only. Alright, so here's our length, here's our breadth. So the product of those two is equal to our area, 204. Expand our brackets by removing the parentheses, and then that is equal to 204. Get everything to the left-hand side of the equal symbol, and that will become a negative 204. Now, factorization in this case might take you a bit of a while, so I'll be using my calculator and looking at the factors of 204. Just a bit of trial and error. We end up getting these two. So we get positive 17 and negative 12. And when you add those, you get positive 5. So there's our combination. There's our two sets of brackets. And looking at our two solutions, we have negative 17 or positive 12. But remember how we spoke about the value of x has to be positive. So we are going to ignore the 17, the negative 17 value, because the measurement has to be greater than 0. So x is equal to 12, so that's 12, and this is 12 plus 5. So 12 and 17 will give us an area of 204, and our value of x in this case is just the one value, which is 12. Okay, our next example is looking at a temperature model, and the temperature is given by this particular equation after a particular number of hours. So H is hours and T is temperature. The question is saying when was the temperature equal to 26 degrees? So that is going to be 26 degrees. Then we have to solve what value of H will be given from that. So there's our quadratic equation equaling 26. We like to work with positive numbers here, so let's get the positive value of h squared to the other side. If I get this to the other side, it becomes a positive 2h squared. That becomes a negative 11h, and taking 21 from 26 is positive 5. So there's our quadratic equation. I'm going to use splitting the middle term in this case. So find two numbers that give a product of 10, positive 10, and a sum of negative 11. Those two numbers are negative 10 and negative 1. So we're going to split up the middle term, the negative 11h, into those two. Negative 10h, take away 1h. When we do that, we have four terms. Looks a little bit more complicated, but let's group them in pairs. Look at the first two. So there's our first two. Factorize the first two, and then there's our second two. When we do that, we end up getting a common term of an h minus 5. That comes out the front. H minus 5 brackets 2h, take away 1. Solving these two linear equations, that becomes a positive 5, that becomes a positive 1. So h is equal to 5 and 2h is equal to 1. So we have our two values. In this case, there's no negative values. If we ended up obtaining a negative value for time, we'll ignore that. but we have half an hour and also 5 hours. So the temperature obviously starts off with something and then goes up, and then you can see that it goes down a little bit. So the temperature is equal to 26 degrees at two particular times, half an hour and also 5 hours. Alright, thank you for watching this video on using quadratic equations with particular problems.